You guys hear me okay?
Mhm.
All right, I had I had muted. Well, we're going to go ahead and get started. First of all, I just want to thank everyone who's joined us for this SCOPES webinar. This is really our community of practice, actually being in practice together and having an opportunity to hear from leaders across our network who are getting involved in primary and secondary education worldwide. And really doing a great job increasing the number of students and teachers who are exposed to digital fabrication. And so as you all know, the SCOPES project, now a few years old, is a research project really dedicated to not just the democratizing digital fabrication like our Fab Lab work, but doing it at the K-12 primary and secondary level. And so today we're going to have a wonderful opportunity to hear from a variety of educators, both formal and informal, from all around the world who have contributed to the SCOPES website by sharing their content. And they're just going to tell us a little bit about how they're using digital fabrication in the classroom, what that means for them as educators, as well as what it means for their students. So I'm looking forward to this learning. And I will also just remind you all that this week happens to be National Education Week here in the United States. And what's lovely about it is this year's theme is Reach, Educate, and Inspire. And I think the work that we're collectively doing as a part of the SCOPES project is indeed doing that for teachers and students worldwide. So there's a lot that we have to share with each other, but there's also a lot that we have to share with the rest of the world. And it's the work that you guys are doing right now that's going to enable us to do that. So thanks to Dan and the rest of the SCOPES team for pulling this together. They answered my call, which was we have to do a better job of engaging this community. Now that everybody showed up, what can we do together? And you guys are helping us do that today. So thank you, and I'll turn it over to Dan.
Thank you, Sonia. Hello, everyone. I'm very excited to be hosting this webinar. As Sonia said, this is our chance to engage with each other, to get to know each other. When we were putting this together, it just kind of occurred to us that, hey, we'd like to hear and meet people that have contributed content to the site. So we just wanted to have a nice, kind of casual and informal way of letting those who have contributed content to share that content, to talk about their experiences. So we're very thankful for the 4 speakers that we have today. I will do a screen share to get us started, and then I'm going to pass it on to the 4 speakers one at a time so that they can share their presentations. We ask that each of the 4 speakers just put together a brief set of slides just to give some background and talk about what they do. So the plan for this morning, for this afternoon or evening, wherever you're calling in from, is to give the speakers a chance to talk for 25, 30 minutes. And then at the end, save your questions for the end, please. You can also submit questions in the chat window if you have questions at the end. So I will get us started here. Just, yeah, quick, Sonia is our leader. Here is our staff, myself, Melvin Leprod, Simone Billings, and Natrice Gaskins have all contributed to the SCOPES project and to putting together these webinars to meet all of you. So that's us. I do want to just give some basic stats on what the community is before we get started. There's 786 members. We have 110 standards aligned digital fabrication lessons published on the site right now that you can go access and use and remix for your classroom. We have 4 special collections of lessons where we worked a little bit closer with some community members to develop some thematic collection of lessons. There's going to be some more in the works, so stay tuned for that. To give you a sense of the kind of global reach that we have roughly 1,200 monthly visitors from all over the world. It's pretty exciting to see the kind of where everyone comes from. I think that's part of our strength as a community. I also want to just highlight some quick references before we dive into the lessons. We have additional resources available on the site, a 33-page playbook, available for download, and Fab I Can statements. It's kind of the Fab Foundation's version of learning standards, learning statements that we feel kind of can help teachers and makers establish kind of a standard set of what it means to to progress in digital fabrication. So without any further ado, I want to just quickly introduce and put some faces to names here of our 4 speakers, and then I'll let them take over and give a more kind of in-depth introduction for themselves. But we have Lisa Bolus from Chattanooga, Tennessee, Supriya Kadam from Beacon Ashram, India, Brandon Prentice from the Trinity Area School District in Pennsylvania, and Henry Sanchez from Lima, Peru. So thank you for speakers. I will now ask Lisa to share her screen and that she can get started with her slides.
Okay, thank you. Okay, I'm Lisa Bolus. I teach at the STEM School Chattanooga in Chattanooga, Tennessee. I teach English 1, 9th grade, and I'm the yearbook advisor here as well. I've been at the STEM school for 7 years, and I came the 2nd year that it was in existence. Our school's been here for 8 years. We're a magnet school here in Chattanooga. I also work with a leadership think tank for ELA, and we help to plan and facilitate professional development for teachers, high school ELA teachers in our county. So that's just a little bit about me. Let's see if I can, there we go. All right, as far as the STEM school is concerned, like I said, we opened in 2012, and at that time we were the first high school-based fabrication lab in the southeastern United States. Our Fab Lab consists of kind of it has 2 rooms, 2 areas. One is a design lab where the kids can actually really write on whiteboards and design and really kind of plan out their work. And then it has a workshop with all the machines, the ShopBot and the laser engravers and, you know, the vinyl cutters and all of those machines and woodworking and places where they can really get their hands dirty. And our main Fab Lab really has kind of become an 11th and 12th grade space where our upper class students can work on their projects. And over the course of the years, we noticed that we were really fighting for that space and fighting for that area. So we created a second mini Fab Lab in our 9th and 10th grade space to give our younger students earlier and more frequent access to digital fabrication machines as well as training, so that by the time they got to be 11th and 12th graders, they were well versed in digital fabrication and how to pull that into their projects. So. As far as the lessons, one of the lessons that I have that's just for my class, and I teach, like I said, English, and so a lot of times English people don't really see digital fab and where that can fit into their classes. They're always like, their math and science do that, you know, but I think English does have a place in digital fab, making all of these concepts and these abstracts more tangible and more visible. So I have an idea to create an independent reading visual representation using digital fabrication. And I'm really hoping, I've been fine tuning it over the summer, working with my principal, Dr. Donan, to kind of really tweak it. And I'm hoping to implement it this spring. So the idea is that the students will use the digital fabrication knowledge that they have been gathering this semester in the fall with different projects to make a tangible kind of visible piece that represents either an abstract theme or a character development and analysis from an independent reading book. So, you know, I'm really excited to kind of see where their creativity goes. I'm a little concerned about them being able to make the abstract visible and tangible, you know, and getting past like, here's my character. No, I want you to go past that. I want you to really look at the analysis and the change. So I have a little picture here of a little kind of a 3D put together puzzly kind of cardboard piece, which is an idea where we can kind of get the students to start making something 3-dimensional, you know, whether there's an object or, you know, some type of element in their book that then they can attach meaning to for the theme. But really the ideas are open for them. Whatever they can do, we're hoping they will do. So the idea is that they will do orthographic drawings and plannings, and then maybe some paper and construction, you know, cardboard kind of models before they really get into the digital fab. And I think that planning piece is going to be really important for them. So my concerns for this project, since I haven't done it yet, this is just speculative, is really time constraints. The spring can be a little hectic with testing, and I'm hoping that we can, you know, really give the students the time to plan and really kind of create. And then, of course, always machine availability. You know, we're always kind of making sure that we can get into the machines when we need them, and then moving past that kind of abstract idea. So, but all right, let's see. Another lesson that I have on the SCOPES website is a cross-curricular lesson. At my school, we actually do cross-curricular PBLs every unit. So 4 units a year, we're doing cross-curricular work with the other, you know, 9th grade teachers. And so like right now we're building robots. The students they're building VEX IQ robots and working on that, and then working with some digital fab in their tech time projects. But this is one that we will actually do in the spring. This is our January project, our cross-curricular Catapult lesson. This really, the focus of this lesson is the engineered design process and iterations, getting the students to see that their first design might not be their final design, and that there's, you know, modifications and changes to be made. So some of the challenges we've had in the past is, of course, availability of machines towards the end of the project, because they're always this big rush to get everything done, and they all want to use the Carby all at the same time, you know, or the laser cutter. So trying to get them to plan out so that we can schedule that for them. This project itself, in the past years that we've done it, really inspired the need for that mini Fab Lab that we have. The need for some, not only training in the 9th and 10th grade so that we can do this kind of work, but also for the machines, for them to be able to do it and not fighting with the upper class projects. So with that mini Fab Lab, the machine availability has gotten so much better. It's made a huge difference for us to have even just a few machines up here for the younger grades to use. At the end of this unit, we really use, we do a culminating event, which I think is huge. We invite families, we invite people in the community, and they do a Catapult challenge. They actually take their final design. You can see some of the pictures here. This is a Bozo bucket challenge where they had to hit it into different buckets in order. And so they have to actually compete and complete these challenges with their final design, and they're mostly for accuracy and distance. So tips for digital fab lessons that I've learned over the years is really the planning is key. Orthographic design sketches with measurements helps to reduce errors when they get onto the machines when they're actually cutting, because sometimes, you know, materials are at a, you know, they're commodity. So you want to make sure that your designs and everything are good to go, your measurements are good beforehand, and that planning is key. One thing that has made a huge difference for us are contracts and weekly progress checks. The contracts for the groups, roles and responsibilities, expectations, and then sitting down with each individual or group weekly meeting, looking at their pacing guide and helping them stay on track so that we don't get to the end of the project and need more time or run out of time. So, and then making sure that your standards are being assessed through this project. It's not just extra or for fun, but this is actually the assessment of the standards that you're covering. So, and I think classroom teachers struggle with that sometimes, especially ELA. So that's all I have.
Okay, thank you very much, Lisa. That was
You're welcome.
very informative. If Supriya is here, would you share your screen, please, and we can keep moving along?
Actually, I'm at outside the lab now. So can you please share my PPT on your laptop, because I'm unable to share my screen with you.
Oh no. Okay. Sure. Is it a matter of time if you go maybe last? Would that give you enough time to get set up?
Yes.
Okay. We'll do that.
Yeah.
So just get settled in, and we'll just have Brandon and Henry go, and then you can close us out. So thanks, Supriya.
Okay.
Brandon, can you share your screen?
Yes, yeah, I'm good. I can share it.
Thank you.
Okay, so hi everyone. My name is Brandon Prentice. I am a high school teacher at Trinity High School, Trinity School District that is. Trinity School District is located in Washington, Pennsylvania. It's about an hour away from Pittsburgh, Pennsylvania. So here at Trinity High School, this is my second year working there. My first year working there, I was more of an instructional coach while also teaching a few periods a day in fabrication or Fab Lab. My second year now is kind of like the reverse. I'm an instructional coach for one period a day, and then I am a teacher for the rest of the day, teaching a multitude of different courses in our technology education department. So, oh, let me get that. So, yeah, so a little bit about me. I got my bachelor's in science and education and my master's in education in tech ed, certified grades K to 12. And I teach, me personally right now, I teach courses in digital fabrication, robotics, video production, advanced metalworking, programming electronics, and animation. So it's a very, very wide variety of different technologies they have me doing right now, which is always great. Also, I am a Fab Academy graduate of 2017. I've always been a contributor to the Fab Foundation for the past, I think it's about 4 or 5 years now. And 2017 is when I took my Fab Academy coursing. So that's just a little bit about me. When it comes to our department, so at Trinity High School, it's grades 9 to 12. The courses that we offer in our department, they're all electives. So as a student in Trinity High School, you're required by graduation to have 4 credits total in electives. And most electives are a half a credit. So whether it's art, music, or technology, or whatever it's going to be. So as for our department, we're an elective. So for all of these courses that we offer, we have digital fabrication. That's a newer course that we've had. Robotics and advanced robotics. Those are 2 separate courses. Metalworking, advanced metalworking, woodworking, drafting, graphics, technology, video production, animation, programming electronics, and small engine repair. So I kind of mentioned to you what courses that I teach. There is a team of us teachers in our department. There are 4 of us total. And our lab facilities, we have 2 separate computer labs that have all design software for multiple courses. We have our actual fab lab, a metal shop, a woodworking shop, video broadcasting room, and a small engine repair room. The fab lab is the newest facility from our school. We got our fab lab from a grant from 2016 before I was hired. And over the course of these past 4 years, we've gotten more and more funding, including adding my position to this department. So including this year, we're getting a multitude of different machines as of this year through another grant initiative that we've had, all focusing in our fabrication lab for new tools and machines and softwares for our students. So what I wanted to focus on real quick is the digital fabrication course. This is the second year of having a designated course in all Fab Lab since I've been working there. That was kind of the point of my position last year, is to create this new course. I had 7 students last year in this course, and it was kind of a experiment for me to see what worked and what didn't work in the time frame that we had and the different machines that we used. So I already said we had 7 students. The Fab Lab approach that I had was, we had all these different machines, and I wanted to give a base knowledge. I wanted to make sure students were using all of these machines all within a semester's time. The reason why this course is a semester as opposed to a year is a lot of other main courses that we offer that students have to graduate take a whole year. So when it comes to scheduling students into these kind of electives, scheduling them for a whole year course is a lot harder to do than a semester course. It's a lot easier to squeeze those in for students that want to pursue something like this as an elective. So that was the idea of why we made it into a semester course. So in this semester, I wanted to give a base knowledge of all different machines that we have, from 3D printing, laser cutting. You see the list of machines that I'm using here, or that we have in our fabrication lab, that is. And I wanted to make sure they had exposure to all these different machines, as well as you see the software that we're using for our 2D vectoring is Corel Draw. For CNC milling operations, it's Aspire with our ShopBot. 3D modeling, we use Inventor because we have drafting courses, as well as using Cura for the tool pathing of 3D printing, and using a PlasmaCam software for our plasma cutter. We have a CNC plasma cutter for any kind of metal designs as well. The scopes, with these, after going over these base machines, I wanted to incorporate a multitude of different design briefs I made for different projects. And with these different projects, I want to give a flexibility of creative design to have the students take control of it. I want to give them a base objective of like making a speaker project or making a LED nightlight or whatever it's going to be, but have them able to customize and make it their own sort of thing from the previous knowledge they've learned from all different machines. So we'd spend like a week on 3D printing, a week on laser cutting, but after all that's done, maybe 9 weeks in, we would then say, okay, let's start this drone design. Let's start from scratch. Let's make a design up for it. Let's start fabricating it, make a prototype, see what works, what doesn't work, do some challenges for it, etc. So when it comes to scopes lessons, I have a scopes lessons for the programmable LED display that you see on my list. I have a scopes lesson for the MP3 speaker design, which I'm actually going to change a little bit. I'll explain that later. And I have one for the drone design as well. I introduced welding to the students since we're doing a lot of CNC plasma cutting. So you see in the one image that I just have them just to introduce welding and plasma cutting. They have to learn how to tool path a silhouette and cut from 1/8" steel to then MIG weld onto another piece of band metal. And also a basic project of CNC pressure fit design, teaching them tolerances and materials and how to do some proper machining with the shop bot in particular. Last year was a goal of I wanted to make furniture. I wanted to actually improve the lab that we had in our school. So they had to be part of designing something that's going to be utilized in future classes going forward. I think I might do that again this year as we keep renovating, we keep improving our lab, just thinking of more projects that can have the students give back and like to the next the next cycle of students that come in. So that's the idea with that. Going back to the real quick is the 1 semester course. I'm thinking next year, I'm trying to talk to my other teachers and my principal about this, but my biggest struggle is finding a way to incorporate all these different ideas into one course where I already said we would make it into a semester. My idea was if we can have multiple courses doing different things. I was thinking about whether it was advanced digital fabrication or maybe a digital fabrication 2, where you can even push yourselves even further into more advanced projects and you're not so tied down to one single course in one semester. And also programming electronics. I'm teaching a little bit of Arduino programming. We have a new milling machine to do circuit design. So I was thinking that speaker project that I had, I wanted to revamp it in a way where we're actually making the circuit board and I can have a whole course in making those circuit boards, which would include a project like an MP3 speaker, or what I have right here is actual Arduino, you can see on my screen, an Arduino that's all made from copper. It's from a CNC milling machine. So having the students empowered by making their own electronics and then doing the fabrication, that's the biggest hurdle for me, is like, where do these fit in? How many courses do I need? But as for my first year trial run, it worked great. We're doing the same course in January, from January till May. I have 12 students signed up this time, so a little bit more enrollment, and hopefully it just keeps growing and growing as the years go by. So that's it.
Great. Thank you very much, Brandon.
Yep.
And just so everyone knows, we've been posting, we posted Lisa and Brandon, your profile in the chat window, which will show all the lessons that you've uploaded for all the attendees to check that out. But we should keep moving along here. We got a tight schedule here, but Henry, why don't you get your screen sharing going and you can take over.
Yes, thank you. Give me a second, please. Okay, this is Henry from Peru. Well, I am CEO and creator of Digitoys. Digitoys is a project where the children can create their own toys, mixing recycled materials and digital fabrication tools. In my case, my life with the digital fabrication started with my nephew Gastoncito. Gastoncito, in some time, he wanted that I buy every toys that we see in the store. I told him, but maybe we can create those toys. So in this picture, you can see a great moment in my life where we create a toys with recycled materials and traditional toys and skateboard because it was his dream in that case. So after that, we create DigiToys. DigiToys is a project. In the next slide, we will see about the lesson in scope, but children can create their toys. Also, I work in Fabric Peru as tutor and creator too, and of course, tutor on FabLab Kids. FabLab Kids is a great project, Latin American project, where we have a community where we replicate our workshop. Several years ago, I participated in a learning community when I understand that since I do with DigiToys have a pedagogical means or minds, seasons. Now I am teacher in a school, art teacher in San Jose de Cluny. And also the last year I create a program for El Salvador, a country in Latin America. So about my lesson in SCOPES, I think it's a great platform to everybody, every teacher can replicate our workshops. In this case, I create this lesson as a gamification a lesson when you can follow from create a fantastic creature in plasticine. After that, you can, or the children can understand the difference between 2D world, 3D world, physical world, digital world. And after that, in the digital world, they can create their own creatures. In our case, 3D printer for us is machines to make toys. In this gamification language, and finally, that children can create this lesson you can find in fantastic creature of DigiToys. There you can find also the slide that we use when we work with children. After that, about my experience with that education, the last year El Salvador has a American school, Escuela Americana in Spanish. They have a Fab Lab, but they needed to understand how to use the digital fabrication in the pedagogical practice. So for 5 months, we have a program with them, similar to Fab Academy. In this case, Tuesday, we have a video conferencia with them, and we show something programs or platforms that we use to create many things in the digital world. And as in the next days, they prove or they test how to use in their classroom many things. For example, in the art, you can see in the picture many another types in the electronic device, creating material to pedagogical material. For example, I have now a timer for my presentation, but in the three picture you can see an animal that like the time is going, the light is on, many things. And finally, with the inspiration of SCOPES, I am creating a platform where the children can learn from home how to use digital fabrication tools and fabricate in a Fab Lab. This platform is digitoys.org. You can find there. Now we have a pilot when the children can create toys like this. After drawing in the book, they can scan with 3D Builder, and after that they can fabricate with machine. That's my presentation. This is my social network. And remember, our workshops in DigiToys are for children between 4 years and 100 years. If you know somebody, pues welcome. Thank you.
All right. Thank you very much, Henry. That looks really fun. Do we have Supriya ready to go? I can share my screen for you, but if you want to share yours, Supriya, please go ahead.
Yes. So, am I audible, Daniel?
Yes, I can hear you. Do you want me to share your slides?
Yes. Please share.
Okay. Yeah, I'm gonna share.
Currently, I'm not broadcasting my video because I'm at a remote location and in my family marriage. So, internet is not good. So, that's why I'm muting the video.
Okay. So your slides are up, so please just take it away. Supriya, are you there? Hello.
I think her connection is just very low.
Yeah. Yeah. But can
Yes.
everyone? Oh, hello?
Sorry, we'll start. Yeah. Yeah.
I can hear you now.
So, I'll start. Daniel?
Yes, I can hear you.
So, my name is Supriya, and I'm working in Vigyan Ashram, DIY Lab. So, basically, I'm electronics engineer, and I'm actually 2016 graduate. So, currently heading DIY Lab at Pune location, which is extension of Fab Lab Vigyan Ashram, and now working on new product development. So, the photo behind my photo is lab in which I'm working. For dome is machine, second one is
I think I might have lost you there. It's too bad. Looks like she had to drop out. Well, I can share Supriya's slides here. If she jumps back in, I'll let her take over.
yeah. Then
Yes, there you are.
yes, am I audible now?
It's a little bit choppy. It's okay though. Keep trying.
Okay, so next slide, please. Second slide.
Okay, second slide. Yep.
Yeah. It is the work area of DIY lab. So DIY is a do-it-yourself lab. So we are running Rex Club for artificial intelligence, in which student, graduate and undergraduate students used to enroll over there. We used to membership role in which school students used to visit lab on weekends, and we run state education programs in school, which are governments and which are in rural parts of India. We also used to run workshops for makers, which are paid. We are running zero budget farming and organic farming, and then we are developing a content for this. We are developing projects, and after that, all reports.
Might have lost you there again, Supriya. I'm gonna go to slide 3 if you can hear me, Supriya. I'll try to take over again. Hopefully she can.
Third slide, please.
We're kind of losing you, Supriya. Are you there?
Clear second slide. So if it's clear, then go to third slide.
Okay, we're at third slide.
Okay. So in all over the programs, the methodology which we are using is, first of all, we are defining the problems with students. We are first of all brainstorming it, writing it down.
Mm. Yeah, I'm not sure if this is gonna.
Hello, hello,
Hi, Supriya.
hello, Daniel.
Yes.
Yes, very sorry, internet is really very poor. But we are defining the problem with respect to the students' curriculum, designing the project and team. Then, according to that, we are tentative solutions and designing activities and source material for students program. So after that, do that project with students, and we make then lesson plans and publish it on CopeDF website or our own website, that is Learning While Doing website. We also used to train.
Mhm. I think we lost you again here, Supriya. That's too bad. I'm going to go to slide 4. Looks like she gives a timeline of some of the projects they've done: lantern making, Diwali festival, paper bags, um, recycling clothes, um, some of the variety of projects that she's done. And looks like here she's outlining some of the problems. A new activity is hard to define. Students are not ready to pay more. So it looks like cost is an issue here.
Yes, Daniel.
Yes. I'm on the
Yes.
last slide, so
So
we need to keep moving. Just
have
time.
you heard? Have you heard my third slide?
I'm on slide 5 now. I'm sorry to have to rush you along.
Okay. Okay.
The last slide.
Yeah. Yeah. Yes, and I want to clear one more thing. Like, these are the list of projects which we have made and we use.
Huh. Just going in and out there. That's too bad. Thank you, Supriya. I think we
No
got.
problem. Which
Thanks, Supriya. It's a little choppy.
for the same education, which is students are not able to use our commercial laser cutter because it is hazardous and it is costly also. So we cannot give that cutter to students independently. So we have developed one laser cutter. You are able to see it in slide number 4. When we had got same education award from Chevrolet, that time we had developed same education school. So that is the laser cutter, which is this.
Supriya?
I think she's just going to keep coming in and out just because of, but for time, you should probably stop.
I agree. Yeah, Supriya, we have to stop with the presentations now, and we're going to open it up to questions. I do want to mention briefly, though, between Supriya and I think other teachers in their lab, they've contributed over 20 lessons to the SCOPES site. I'm not sure if anyone's had a chance to. I'm going to try to put the put her lesson link in the chat window. It's an impressive amount of work that they've all done. So I just want to make sure that we acknowledge all the amount of work that Supriya and her team has done by adding so much work here. So I just want to share that. But then if there's any questions that if any of the panelists have for each other, or if anyone listening in on the webinar, attending the webinar as a listener, now is a time to ask questions of any of the speakers.
We do have a Q&A, so I do have a question in there.
Great, go ahead, Natrice. Natrice?
For Brandon, question is, does the digital fabrication course receive credit towards graduation? And if so, what type of credit is it under? Math, science, etc.
Yes, so our courses that we offer in our department are all elective courses. And so including the digital fabrication course, it is an elective. It'd be a half a credit for a 1 semester course. And students are required to have 4 electives, 4 credits, I'm sorry. So 4 credits total in electives by graduation, whether it's art, music, technology, it's whatever they want to pursue. So everyone in my class chooses to take digital fabrication.
And that's the only one I got in the Q&A. So the others, if you can raise your hand, I will let you, you can talk at that point.
Lisa.
You can also put it in chat and I'll catch it too.
Okay. I have a question for Henry. So, Henry, is there ever an opportunity for children to come into the Fab Labs to create their toys with the DigiToys, or is it all remotely done?
In the last until now, we have physical workshop of the children can create. For example, this is one space of Fab Lab Peru, and we have the 3D printer, the laser cut. But now I am translating all my workshop, physical workshop on an online platform via video tutorials, some exercise, and after this is thinking about the scaling, because we need to scale to go to many children in the world.
Lisa, I have a question for you. Something I've noticed with all you Chattanooga teachers, the planning is really impressive that you put together, and like the document that the pacing guides and the write-up that you share in the lessons is such like a really kind of crisp, like thoughtful document. Can you talk more about like what the planning process is for you and your colleagues and the principal? How does that work out?
Absolutely. We have common planning time with our 9th grade team, and that's usually where we start. If we have an idea for a project or if we're tweaking a project, we meet as a team and kind of gather up all those ideas. And then once we kind of have kind of a skeleton of what we want to do, we will meet with Dr. Donan, our principals, our tech time teacher, Mr. Van Zant or Mr. Kranz, who run the Fab Labs and the mini Fab Labs, so that we can see how it's all going to kind of fit together. And we kind of work in tandem. You know, we bring the big ideas and what we want it to look like and how we think all the subject areas would kind of fit in. And then they kind of help us make sure that it's possible. And then between all of those minds together, we'll draft the pacing guide together, you know, the steps for the different iterations, so that we can make sure that the students are really going through the engineering design process. Because for me and for us, really, the end design is not always the most important part. You know, sometimes it's the process. Most of the times it's the process and the planning and getting them to learn how to plan and sketch and design and redesign and modify and, you know, reflect, especially too. So we want that to be part of that, but we do have multiple meetings. Like we're planning a PBL for the spring, a new one for the later spring. And we've already met about that one. We've already kind of put the bare skeleton together, and we have another meeting before we leave for winter break. And then we'll have another when we come back in the spring, just to make sure that we put all those pieces. So I think common planning time is really important.
Thank you. Are there any other questions from the community attendees or anyone in the chat? Have any questions for our speakers?
I just let Nathan know that we had, who wanted to see Henry's lessons, that the link is in chat for all of the speakers and panelists.
I have a question, I guess, for Henry or Lisa. When it comes to the workflow of your fabrication labs, how much do you do as an instructor? So like, for example, me, I teach all the software, the students make their designs, and then usually, depending on the machine, if it's a laser cutter, they can just do it on their own. I have them take the file over, laser cut it, do everything. Some more advanced stuff like the ShopBot, I might have them do tool pathing, but then I would actually execute all of the actual machine operations just to make sure everything runs smoothly. So, I mean, are you just present during the workflow, or do you give them full control, or how do you do it?
I'll start. With our Fab Labs, we oftentimes have student experts. We have a digital badging system where students become experts in different machines. And they're really just kind of pushing this out now. A lot of our upperclassmen have these digital badging where they're experts in the ShopBot, or they're experts in 3D printing or digital fabrication. And so we can actually partner our underclassmen, our 9th and 10th graders, up with, you know, those experts to actually kind of guide them through the process. And these students have been trained on those machines. We also have, you know, our Fab Lab teacher, at least for me as a classroom teacher, I have the Fab Lab teacher as a resource, our Tech Time teacher, who's our mini Fab Lab teacher, as a resource. And I know that in Tech Time, they're doing mini digital fab projects to become more versed in these machines. So by the time they get to me in the spring, they've at least experienced them. And then sometimes even in the 9th grade, we have expert teams. If we see that a student's really well versed at using, you know, the Carvey, they've gotten really good at the Carvey, we'll make that student an expert in a project. And like, you're an expert in this project, you're going to help people work their way through, you know, that machine. So using student experts, I think, is really, really helpful, you know, making sure that they're trained in safety and in those machines, and then, you know, passing some of that off to students who honestly are sometimes better than we are anyway. So that's what we do.
Yeah, in my case, in my work with the children, I train in them to use the 3D printer. They can use alone the 3D printer, but in the laser cut, we need a support. Maybe in my case, here in Peru, in Latin America, the children know me as Uncle Henny, Tío Henny, because of my nephew Gastoncito. In that case, that case in the physical workshop, in the online workshop, the children design in their home, and when they finally have the design, come to a Fab Lab. In this case here, but the idea is that they can go to any Fab Lab around the world and fabricate their own toys.
Awesome, thank you.
Do you have a question from Alethea Campbell? Her question is, for each panelist, what they find the most challenging aspect of teaching digital fabrication to new students and learners. So those are new to digital fabrication.
I guess, like I said, this is my 2nd year working here and 2nd year trying this course out. My challenges last year would incorporate new and experienced learners. So half of my students were very well versed from just taking other courses in our department before I was hired, and a couple other ones were brand new to everything. So keeping them on the same page, keeping the more experienced ones busy, especially during the first 9-week process, because like I mentioned, the way I structured it was half the semester is usually trying to expose everybody to every machine by doing some kind of introductory project that they can all make. It's kind of like my own internal badging sort of thing. By the end of the semester, they'll be able to utilize whatever machines they have to make their speaker, make their drone. I give them full creativity when it comes to materials and processes, but they have to first know everything. So yeah, going back to my biggest challenge would be keeping everyone on pace, basically, new and experienced students in my lab.
I think for us, the younger students, especially 9th grade students, the biggest challenge is getting them to slow down and plan and really kind of, you know, sketch it out, do the measurements, you know, plan what you're trying to do so that when you get to the machine, they're going to be more successful because they want to jump right to the machine. You know, they just want to, they want to jump in, which is fabulous. And we love that energy, but teaching them that there's a process and that the process can make it better. So having them slow down through the process, the sketching, the planning, you know, checking off and signing off on their designs on, you know, Corel Draw or Tinkercad or whatever it might be before they jump into that machine. You're getting them to slow down a little, I guess, and be purposeful. So.
Yeah, in my case, well, my great challenge was to understand the children language, because when you as an adult teacher or tutor propose many things to the children, maybe they didn't have interest about that, but the children, the only thing that need is to be happy, and they are happy to play. And if you this toy, you can create this, you can change this toy as a project, and a project they can learning about a digital fabrication tool, about maths, about science, about many things. After that, if you can communicate very well in a gamification classroom, the learning is more easy.
Supriya, do you have are you still on the call? Do you have any challenges that you find with your students?
I can say one more challenge if she doesn't. I mean, going back to my introduction, I kind of was hinting towards this, is finding a way to get all the content, all the processes in a short amount of time. So my answer was maybe coming up with more courses. For example, I have things around me, around my desk. So we have 3D scanning technology, as well as using a rotary indexer on our ShopBot. So learning how to carve 3 dimensions out of wood. So that's something it's like, well, I'm introducing the ShopBot with students, and then we go over to the next process, welding or whatever it's going to be. But like, to have them go through this kind of process would take at least a week, especially to fabricate and go through the whole process of making their head out of wood, or if it's 3D printed, I guess. Casting and molding, we do a lot of, you'll notice in my SCOPES lessons on the link that I have a sand casting aluminum parts lesson. That's more my advanced metalworking course, not my digital fabrication course. So for example, this is something for fishing, wherever you like hook the gill of a fish, you can actually hold the fish up. In case the fish has any kind of teeth, you can't lip them. But you have to learn how to 3D model a part out of wood and then press it into sand to then pour molten aluminum into it to make your finished part like this. That's something I can't do in my digital fabrication course. I need to create some kind of newer, more advanced course that has a prerequisite to digital fabrication, but they can do stuff like that as well. And I already mentioned the Arduino that I made, so any circuit design, I need to either find a way to make an electronics design course or production course, or just find a way to incorporate programming into a more advanced Fab Lab course in itself. So these are all just ideas in my head. These are the different capabilities that my facilities have that I want to utilize, but having that one introductory course is a little challenging, getting it all squeezed in.
Nice, thank you. We just have a couple minutes left, so if there's any more questions from anyone in the attending, please raise your hand or put it in the chat. We'll try to squeeze it in. This has been really informative to hear the 4 of you talk. So I just want to thank you for your time this morning and for putting together little presentations to share your work. We will make it available, make your presentations available kind of as one kind of long summary, or if you would, of this webinar for those who want to kind of look a little further into some of the resources and links that you shared. I think that'll go a long way. We also have a post webinar survey that we'd ask people to submit. I think it's about five minutes, just to kind of help us improve our process here. Looks like there isn't a question here. One more question, and then I think we gotta let everyone go. How do you work with students towards a complex project, especially if they don't have sufficient disciplinary knowledge to design and build it. For example, a drone. Does anyone have an answer? It's kind of a big question, but
I can answer. Well, I mean, with me at least, I kind of been repeat myself, but like I have this idea of like my first 9 weeks of a semester course, I would go over all different processes. I want to make sure that everyone goes through their own kind of badging in our class, so they can't proceed until they actually complete all of the introductory projects. So by the time we make it to actual something like a drone, I give them the structure, like here are the dimensions. You'll see it in my scopes lesson that I give them like parameters, like here's what the sizing has to be and so forth. But they have to pick their own way. It's like pick your material, pick your machine, what process you want to do, like what kind of prototype do you want to make. If it's a drone, you want it to be lightweight, you want to make sure it fits the requirements, the dimensions, etc. So I mean, they should already be aware of everything that we have capability-wise by the time they make it to one of those projects, which is in the second half of the semester for us.
okay.
I'd like to answer that one too, if I could. Just briefly, I think it's all about scaffolding. Like we scaffold in the classroom when a student doesn't have the skills to do a complex task. I think Digital Fab has to be the same way. And Brandon, I wasn't sure if you're partnering with classroom teachers to help them, you know, with that scaffolding, where like we partner with our Fab Lab teachers, our tech time teachers. And if I'm going to do a complex project where I'm going to be asking them to use laser cutters, then I know I'm going to go to my tech time, you know, person, my Fab Lab person early in the year and be like, could you help me make sure they have these skills? Could you do a little mini project? Could you do some lessons? Could I come in and do some lessons? But scaffolding that work, I think, is really key, because we wouldn't toss kids in and expect them to write an essay the first day of school if they've never had those skills. Same thing with these machines. We have to scaffold and plan, pace it out for them, I think is really important.
Awesome. Yeah, that's great. Well, if there's nothing else, we're past 10 o'clock, so I don't want to hold people past, but appreciate. So I think it's a good sign if you go over time, right? That that we're all excited to talk to each other and hear kind of best practices. So again, thank you to our 4 speakers, Lisa, Supriya, Brandon, and Henry. Really appreciate the time and energy, and thank you everyone for your time, for listening in. We will be doing similar type webinars in the future with other lesson contributors. So if you're interested, please do let us know. We'll be in touch as well. But we look forward to more of these in the future. Please do check out the lessons that each of these teachers and makers have submitted on the site. They're really nice, and they kind of represent a nice range of approaches and styles and content and the different technologies. So they're really quite nice work. So that's all we have, Natrice. If you don't have anything else, I think we can stop recording and say goodbye to everyone. Okay.